Welcome to this video on the topic of vectors. In this lesson, we're going to have a look at how we can represent vector expressions geometrically. Of interest is we're going to summarize the vector addition operation, then we'll have a look at the subtraction, and we'll finish off with the dilation operation. So, to summarize, vectors may be summed by combining them tail to head. For subtraction, the direction of a vector may be reversed. For multiplication and division, the length of a vector may be carefully dilated. And I put a disclaimer on this final sentence over here because technically for vectors the division operation does not exist. Furthermore, the word dilated simply means we change its length. So the length of a vector is either shortened or enlarged. Now let's have a look at what this means by example. Let us consider. We will look at three different vectors, and in this video I'm going to draw them carefully. First one we're going to have is going to be vector A. The next vector that we're interested in is going to be vector B. And the final vector that we care for is going to be vector C. What we're going to do is we're going to do some operations on these. Firstly, let's define ourselves a vector expression. We want to represent, and let's go A, take B. So this is the expression over here that we want to represent geometrically. Now, in the last lesson we had a look at what we would do if it was A plus B, in which case we go from tail to head, tail to head. We're still going to use the same method, but before we can do that, we're going to rethink how we look at this expression over here. Rather than thinking of it as a take B, what we can think of it as is vector A plus the negation of vector B. So vector B reversed, and the minus B being its vector in its own right. If you want, you can just go that, or you can do the full filter over there. I might just do it like this because it looks tidier. Okay, what we're going to do is we're going to, well, firstly we can deal with vector A. So let's just get a copy of it and carefully redraw it over, and there we go, vector A. Next we need to think of vector B. Now if you look at vector B over here, it points from left to right in a horizontal direction. What we're going to do is we're going to reimagine this vector. Rather than think of it as vector B, we're going to think of vector negative B. Now if we go up and we have a read, we remember that for subtraction, the direction of a vector may be reversed. So rather than thinking of vector B as pointing from left to right, let's think of it as negative B as pointing from right to left, because we're simply just going to reverse this. So I will get this guy over here, sort of fine, move this up here, and rather than having the arrow like it's shown over there, I'm going to reverse it. So now this vector represents B, but in the total opposite direction. So if I want to simplify, or if I want to represent this statement over here, then I simply grab vector negative B and I sum it tail to head, just like before. And therefore, the resultant representation of vector A take away vector B is simply going to be as shown here. So this is A take, or the reverse of vector B. And that's fine, this works out. Now another way you can think of this is you can get vectors A as shown over here, and then we can go up and we can grab vector B shown over there. And if we want to do subtraction, then we can go head to head. So the two heads are pointing against one another. And if you're tracking this visually, you would start off at vector A over here and you'd go up. And then because you're going in the opposite direction to what vector B is telling you, that's actually negative vector B. So, broke it. So we end up getting the same result. Now both of these modes of thinking have their own merit associated with them, and you will use both modes of thinking as you're working through this course and in the future. But this one, the first one on the left, this one is nicer to look at and it makes more sense, but the one on the right as well, it's still important to know how to do, so I'd recommend working in both ways. So this is how we do subtraction using vectors. We simply take the negation of the second vector, or alternatively, you can then just work in the opposite direction to what the vector is going in. This being more intuitive, this being less intuitive, but it works. Alright, now next thing we need to look at is dilations. Suppose we want to go vector C, no, in fact we'll go vector 2A, then we will go vector 3B, and we're going to take half of vector C. Now we can already deal with the negative here because we remember that this operation is just going to be distilled down to the reversing of vector C. So it's just going to point in the opposite direction to what it originally pointed in. But what we haven't seen is we haven't seen this half symbol over here. We know how to dilate vectors by integer values of 2, 3, whatever. But what do we do when we're trying to dilate it by a half? Because we can't stick half of two vectors together. So let's start off by going the 2A and the 3B, and then we'll look at C. So doing this, I get the A, and I know there's going to be two of these guys. So I'll give myself some space, and I'll put one there, and then I will put one here. And I'm going to line them up as best as I can, but working on a computer it can be a bit tricky. So there's our 2A. Next, we need our 3B. So B is over here, let's just grab it, and we're going to go 1, 2, 3. So that works out. Now, I could leave it like this, but a better way or a simpler way to do this as well is drawing it like shown. So rather than just having 3 lots of B, I can dilate it outward so it's now 3 times the original size of B. So this is 3B over here. 2 ways you can do it. You can stack them, so stack 2 of them, or you can stretch it out by a factor of 3. Now the final one is we've got this half C. Firstly, let's go get negative C. So I go up. This is C over here. If that's C, then by reversing it, I'm going to get negative C. So let's get rid of that and that. Reverse the direction, and then we're going to get negative C. Now the next thing I need to do is I want to dilate this, so this is half of C. So what I'm going to do is I'm going to get my ruler, and then I'm actually going to measure it. Now this one measures 3 squares, so the best I can do is I can say this is going to be 1.5 squares. So this is negative a half of C. So remember, we can't divide it, so we dilate it by a factor of a half. Next, I simply grab the vector that I'm using and I plop it in where it belongs. In this instance, I'm always going to go head to tail. So up we come like that. To finish this off, the representation is going to be shown by the vector that goes from the starting location to the end location, or the starting tail to the finalized head. So I get my ruler to line it up as best I can. This one will be tricky because I've only got increments of 1 degrees, where you guys have infinite. And it's going to go just like that. So this statement over here is going to be 2a plus 3b minus a half of vector c. So in summary, what we had a look at in this lesson was firstly the rules associated with operations we can do to vectors. So we can do subtraction, and the way in which we do it is we simply reverse the direction of the vector we're working with. So if I have positive b over here, I can take b by simply reversing its side and saying it's now negative b. For multiplication and division, we simply dilate the vector by a factor.